Many of our customers are not aware of the technological advances under their car's bonnet, let alone the expertise needed to repair them. Even the simple fan belt is evolved to a wonder of automotive design. Today's drive belts perform a very specific task of transferring crankshaft torque to all of the accessories needed to keep the modern car functioning. High current alternators, air conditioning compressors, power steering and water pumps need a reliable means of receiving power from the engine's crankshaft to operate. The drive belt used for this task must operate in extreme temperatures, wet and dry environments, must be resistant to oils and other engine fluids, and also retain a specific tension. Serpentine drive belts are the choice for vehicle manufacturers because their design provides better belt-to-pulley contact with less slippage when compared with a conventional V-belt. Modern serpentine belts are manufactured using an ethylene propylene diene monomer, or EPDM type material. This provides increased flexibility and greater torque transfer with less slip when compared with older neoprene designs. It's the use of EPDM that helps with resistance to fluid contamination and is one of the main reasons we're seeing these belts last well over 100,000 kilometres. A standard SAE measurement system has been adopted for identifying and measuring multi-rib serpentine belts. For this belt, 6PK1050, the first digit gives the number of ribs. The letter P refers to the belt section, P for polyrib, and K means it's an automotive design belt, with the 1050 as the belt length measured in millimetres. Multi-rib belts are available from 3PK to 12PK depending on their designed use, and can be engineered to suit either petrol or diesel engines. The diesel grade belt features higher performance construction over conventional types in order to meet the high torque and power pulses exerted by these engines. The specially treated cords within the belt resist stretching and ensure length stability that is essential for high output diesel and petrol engines. Belt manufacturers have even progressed from a polyrib V-groove to a W profile that can flex and move in response to changing pulley and tensioner designs and help minimise noise with wearing components. When we look at accessory drive belts, we really need to talk about the entire accessory drive belt system. A pulley is a grooved wheel whose purpose is to transmit torque to driven components in the accessory drive system. Pulleys are available to suit the belt that drives them. Most pulleys are designed to be replaced as a unit when needed. Overrunning alternator pulleys allow the alternator to freewheel when the belt speed drops and are engineered with a one-way clutch that allows the rotational inertia of the alternator to overrun during any belt deceleration. In contrast, an idler will generally be designed with a flat roller, enabling it to run on the back side of the belt or grooved to operate on the inside. An idler's purpose is to optimise belt routing, suppress belt span vibration, or provide a means for tensioning the drive belt. Newer vehicles that employ a serpentine belt system often use an automatic tensioner to apply a constant force to the belt. This tensioner is able to compensate for belt length due to wear and changes in accessory drive operating load. The tension is supplied via a spring mechanism mounted behind a pulley and lever device. Automatic belt tensioning reduces maintenance by eliminating the need to retighten belts each service and eliminates bearing and premature component failure from over-tightening of the drive belt. The modern accessory drive belt components are closely integrated, and a problem in one of these will affect the others. Just like a V-belt, the polyrib serpentine type grips pulleys from the side of its rib section, not the peak or trough. Belt wear can be difficult to detect because they wear from the rib edges, resulting in material loss from the ribs. This can cause slippage that will affect the performance of the accessories. All serpentine belts need to be closely inspected to identify any wear. These belts are asked to perform in extremely hostile environments under the vehicle's bonnet. Regular inspection of all drive belts and accessories should be performed at each vehicle service or inspection. Belt wear can be checked using a simple tool like this one. Start by inserting the bar into a groove of the belt. Don't tilt the gauge above or below its surface, and keep the gauge parallel. A new belt will show the top of the bar to be higher than the tip of the rib, with a worn belt displaying the bar below the rib tip, indicating wear. The profile of the belt's ribs can be checked by inserting the teeth into the belt grooves. A new belt will have no side clearance between the tooth and rib. A worn belt will present with bottoming of the tooth into the belt groove, and a noticeable clearance will be seen between the side of the rib and the tooth. As serpentine belts age, we begin to see surface cracks on the ribs. But what is acceptable? Place the tool window lengthwise over the rib section of the serpentine belt. If there are 4 or more cracks within the 1-inch window, it's recommended that the belt be replaced before complete failure occurs. Belt tension can be checked using a simple tension gauge. Place the tension gauge in the centre of the wider span of the accessory drive belt, keeping the rear chamfer parallel with the back of the belt. Press down firmly until the tension gauge clicks, and be careful to keep pressure at the rear. The tension will be displayed where the blue pivot arm crosses the scale. Check this value against the vehicle or belt manufacturer's specifications. A laser alignment tool can be used for checking pulley or tensioner, axial or angular misalignment. Place the tool on the crankshaft pulley, making sure it sits in the grooves correctly. The laser will turn on automatically. Now we need to aim the light at the pulley we want to check. Place the target piece into the corresponding groove on this pulley, ensuring Dayco is in the same alignment as the laser body. Slide the target piece around the pulley until the laser dissects the target line running through the centre of Dayco. If the pulley is in true alignment, the laser will follow this line perfectly. Axial misalignment is evidenced when the laser is parallel with the target line, but on a different plane. If the laser is not parallel with the target line at all, then angular misalignment is the fault. If there's a problem with the belt or any of the accessory drive components, they all suffer. These systems are doing as much work as the vehicle's crankshaft, and so deserve our undivided attention. Thanks for watching.